think I need to spend any of the time that we have this evening introducing Larry Tesler, because his talk is going to astonish you with how many times he was involved in making decisions and observing and researching and creating things that we all take for granted. This is a reprise of the talk he gave when he won the Lifetime Achievement Award this year in Vancouver at the national conference, but international, you're right, the international conference, you're right. By the time you cross the Canadian border, you're already internations. So without any further introduction, Larry Tesler.
Well, thanks. It's very fitting that this event's at PARC. I'll be talking quite a lot about things we did at PARC today. What I'm trying to get across today is what it was like to design software that billions of people, I don't know how many actually, but billions of people either now or will in the future use on a daily basis in most every application on most computing devices. So it's, I did intend it to be universal, but still kind of astonished me how widely used these couple things are. And the other thing I'm going to talk about, though, is how it happened, and you'll see that it's a combination of many factors, but one of the primary factors was the colleagues I worked with, because none of the things I did I could have possibly done by myself. I had a lot of collaborations at different points with different people, and it was that mix that made all this possible. I'm going to go through very quickly on this slide my career overview. Then I'm going to go painfully detailed through certain parts of it that may seem really kind of irrelevant when you first hear, but it'll all come together as I go through it. My career has actually oscillated quite a lot on 3 different dimensions. One is between research and practice, product development. Another one is between engineering, which is what I was originally trained to do, and user experience, which I had to pick up on my own because the field really didn't exist, and between managing and doing actual work. So all of these activities were intertwined, and as you see, as I went through, not exactly on a decade basis, but every 7, 10, 17, some number of years, I moved on to something else. And but through the process, I got to work for a lot of interesting places. I'm going to mostly talk about work I did in the 60s that was really kind of preparation for the work I did here at PARC in the 70s, which was preparation for what I did when I got to Apple in the early 80s. So it's the top part of the chart. Wrong key. There we go. I started programming when I was in high school in the late 1960. So that's 51 years or something like that. The high school had no computer. I don't know if any high school had a computer at that time. But Columbia University had a small number of computers, and that was just downtown from science. So every other Saturday, I'd get in a train and go down to Columbia and go into this room where the 650 was. Anybody ever use a 650? Did you actually, anybody ever use that 650? No, okay. But we have a couple here. I only got computer time for a half hour at a time, but it wasn't even a batch computer. It was a standalone, one person using it at a time computer that you operated by punching cards, putting them in a card reader, getting printouts from a pretty slow printer, really, if you could even get your program running. And the problem was that in 30 minutes, given such a slow device, it was hard to actually get one program to even compile, let alone run it. So I didn't make much progress. And that's about when I would, on my train rides home, go, I wonder how I could get my own computer at home. It would have to be smaller than that thing. In the fall of '61, I started at Stanford. And within just a few hours, I met some fellow students who went to Pali High and actually had access to the computer center. So I got them to take me over there, And I spent the next 4 years at the computer center and kind of being a student at the same time. I worked at the beginning part-time as a computer operator, and that was really great because I got free computer time, I got a paycheck, and I got to talk to people who were having problems with their programs and started understanding that, you know, it's the way the software was written. We didn't call it software yet, but I'll say that word sometimes. The way the programs were written is making it hard for this person. But we had kind of an excuse in those days, which was these computers had tiny amounts of memory, like a few K bytes. And just to squeeze the program in and get it working was phenomenal enough. To say that it was easy to use was way down on the hierarchy of needs, which we also didn't talk about then. So this photo here shows two of my friends at the Burroughs 220 computer. The one in the front is Larry Breed. The one in the back is Charlie Brenner. And they're both went into computing after college. Larry worked on implementing the first implementation of APL at IBM. And Charlie became a forensic computer scientist and figuring out from DNA, you know, whose dead body that was, that kind of stuff. But at that time, Larry had been approached by a computer science professor to be recruited onto a project with another student, Earl Bobert, to develop something called the Stanford Card Stunt Program. And what that was about was it was an animation language for doing the halftime card stunts at football games. Well, at that time, there were 0 animation languages, and there were 0 programs that could deal with what we call raster-based displays now, you know, pixels, rows and columns. But that's what this was. It was rows and columns of students holding up cards. There were 77 times 45, I guess it was 77 seats, 45 rows. So that was 3,465, if I remember right. I didn't just do the multiply. And each student had 6 cards under their seat, which they'd put on their lap when it came time for the stunts. And they'd pull one up and either show you the front of one of the cards or the back. So there were a total of 12 colors, not millions, not thousands, not even 256. We had 12 colors, which made it easier in some ways. We could remember all their names. But they had to do their flip, what we called it, which was what we call frame today, on a call from a yell leader at a microphone calling out numbers. And then they matched up the numbers with an instruction card they had. So this is what the instruction cards look like. It says things like up on 1 white, up on 2 black, up on 8 white, up on 9, and then 9 down. So that means at flip 1 you hold up white, then 2 black. When you hear 8 you hold up white, and then at 9 you put it down. Every student had something like this, and they would go through the sequence, and hopefully if it was done well across the stadium, people would see this animated stunt. But the problem was this isn't the way it was yet. This is the way it became, because before that there were handwritten cards that an army of students had to write by designing these stunts, drawing them out, transposing it into what would happen at each seat, and amazing charts, and then people copying from their row of the chart onto these little cards, and then sticking the cards at the student's seat on Saturday so they'd be ready for the game. Anyway, they were really having trouble getting students. This was the early 60s. They were having a lot of trouble getting students to do this work anymore. And so they decided they ought to automate it, and they went to Larry and Earl, and they wrote this program. The language that they programmed in was a declarative language. And what that means is that each statement stood by itself, and the order of the statements didn't really matter. So if you told the program to expand shapes 3 and 4 by a factor of 5 between frames 6 and 12, then it would wait to frame 6 and then start doing stuff up until 12, and then it would stop. And then you could describe what would happen to some other shape. And so you could have one shape going like this, another shape starting a little later going like that, and it was all about having these asynchronous kind of or uncoordinated things going on, multiple threads basically going on. Independent, yes, that's the word I was fishing for. But there was a problem with that, which was the program was in a very elegant language, but it was all numbers. Larry didn't have time to ever write a parser. And the computer was kind of small, so writing a parser wasn't a trivial thing. So he just got around to getting this far. You'd write something like that. And that might mean something like, expand object 3 by a factor of 4 between so-and-so frames, that kind of thing. And then the idea was that they would teach the artists who were drawing the stunts how to code these, and then give them to key punchers, and the key punchers would punch the cards, and so on. And then it would all work. Well, didn't really come out that well because the students made lots of mistakes. This language was kind of hard to read for sure, but it was even hard to write. And when something went wrong, they were totally lost. So Larry came to me at the end of my freshman year and said that he was graduating, and which was too bad. He'd been quite a mentor for me, teaching me excellent programming practices, and also instilling in me an interest in elegant everything, including the ease of use of things. So he was actually a bit embarrassed by the fact that this was just all numbers. He just never really had time to do anything about it. He said I should really put in mnemonics and make it a lot easier. Otherwise, I would have to code all the stunts myself because the students really wouldn't do it. So at the end of the talk, I'll list several takeaways that you can make, but the first one is this. Unless you want a career in operations, build easy-to-use, bug-free software. That's where I learned that lesson. So the first thing I did was implement mnemonics. So instead of 7, 3, 4, you could say expand shapes 3 and 4. And then 5 was how much you expanded it by, and then flip 6 and 12. Those were the beginning and ending frames, and then 0 terminated it. So I made these up. I'm not sure these were the exact numbers, but they were equally obscure. So I made it so you could have mnemonics. I just made a little tokenizer and did that. Didn't really need a parser. So I thought, great, now they'll be able to do it, and I won't have to do anything. They'll just turn it over to the key punchers. But it didn't really work out. They still made a lot of mistakes. So here I was, first time I'd ever written a program for someone else to use, and I didn't really know anything about art, still don't. So I thought, what am I going to do? And somehow I got the idea, what I'll do is I'll meet with the artists, and we'll pick a stunt that they need to code anyway, and they'll code while I'm watching. And so I started doing that, and I just would watch them code. And then sometimes I could figure out what was the problem, and other times I thought, why'd they do that? What are they thinking? Why are they just sitting there? So I started saying, could I ask you to tell me what you just did? And after a while I said, could you just tell me everything you're thinking as you work? And they started talking out loud while they were doing this. And I went, oh, this is pretty cool. This works pretty well. And I'd never taken a psychology class. I'm not sure whether what I would have learned would have made me do that quicker or maybe stay away from that technique because I was meddling too much and interfering with what they would do naturally. But I did learn an awful lot. So that was kind of a talk aloud usability study. Then after we were done with that, they said, what are you going to do? And I said, well, I want to try to make it easier. So I ran some ideas by them, and then they also came up with their ideas of their own, and soon we were sitting down together brainstorming how we would fix this. These are pretty, smart Stanford students in the art department. Didn't know anything about computers, but who did in those days? And we came up with ideas. So one that we came up with was just to, when they ran into this kind of thing where they were defining a new shape, there was a list of XY coordinates, 10, 5, 25, 20, 15, 10, 15. And they were just like that. Well, sometimes there was a list of hundreds of these. And somewhere like on the 75th one or something, they would accidentally leave out the X coordinate and then move on to the next X coordinate. And then make a similar mistake later on. And so for this whole part of the stunt, even if the program counted and made sure there were an even number, it could be that like right in the middle of the polygon, all the Y's and X's were reversed, and of course that made a bizarre figure on the screen. So we brainstormed the idea of just very profound, just putting commas in after the Y coordinates. Now it's pretty obvious now, no one would ever do the thing that we did first. But we had to think about this and came up with that idea together. And then it turned out to work very well. There were lots of things like that we developed together. And that was a participatory design exercise. And it was a discount method, I have to say, because there were just like 2 users and just a few hours of work, and I didn't have to pay them anything. But one thing you shouldn't assume is that the word field study came from Stanford Stadium, because it didn't. That wasn't really part of the derivation of that word. Okay, so after fixing these things, the next version of the program was usable enough that I rarely had to code a stunt myself. Once in a while, I'd have to fix a little glitch somewhere. And so that worked pretty well from 62 to 64. And then in 1964, there was another student, Barry Flashbart, who was very interested in end-user programming. And when he heard that I had done this, or Larry had done this, and I made it better, he started looking at it himself. And he came to me and started commenting about it. I said, well, have you actually used it? And he said, no, I'm just applying heuristics. I said, oh, what do you mean? And so he said, well, for example, it's a declarative language, which means that the order of the statements can be anything. So if something goes wrong, the student is not going to be able to, or the art student, is not going to be able to tell what the problem was, because this object's moving this way and that object's moving that way, and if you have another statement that moves this object that way by mistake in the same frame, then the object won't move at all or go backwards. I mean, something weird will happen. And they just won't know where to look because there are statements all over the place, not in any particular order. He said, we really need an imperative language. It may be a little harder to code, but it's going to be a lot easier to debug. So I thought this was kind of interesting that somebody, without even running a user test, could come up with this. But it sounded reasonable. So we did go ahead and actually recruited some students and re-implemented the whole language yet again and made it an imperative language. The problem was that it was harder to code, because if you had multiple objects moving in different directions and overlapping their start times and end times, it became very, very complicated to do. And the reaction to that was that the art students stopped designing stunts like that. They made way simpler stunts. So if you look at Stanford card stunts from about 1966 to 1970, which is when it ended, they were pretty boring stunts. And that was because of that change. So really, that was a trade-off between ease of use and ease of learning and ease of debugging. And does anybody here work in end-user programming or have? If you do that, that's classic trade-off between those or among those different things still today. Let's see. Okay, where are we? 60s. So I already told you about the art students and the participatory design. In 1963, I was getting lots of people asking me to do programming for them, and so I formed a company. And at one point, hired 4 people. Most of the time, I had maybe 1 or 2 people working for me. My company was the 5th software company in the Palo Alto phone book. And at one point, I think we were the 2nd or 3rd largest software company in Palo Alto when we had 5 employees. And there were about that many computers in the Palo Alto area, too. But I was only 18, and in those days, it wasn't common like it is today for an 18-year-old to be running a software company or any kind of technology company. So I had to buy a suit and tie and make myself look older. And I got away with people thinking I was 30 because my hairline was already high, and I had the tie. So I got professors and grad students who didn't care how old I was, but I also was getting local businesses to hire me as a consultant. And it kept me very busy and made it hard for me to find time to do my studies. So I barely graduated, but I finally did. Some of those customers wanted me to write programs that had some kind of user interaction. In the early days, that was filling out forms and then entering the data on cards, but then it moved over into time-sharing systems with terminals and text-oriented user interfaces, and a little bit of graphical user interfaces at that point, but not much of that yet. So for the ones that had anything interactive, I was able to start doing, again, my participatory design and try to make things easier to use. So that was In the 60s, I developed not only my programming skills and some business skills, but gradually my user experience skills, intermittently. Malcolm Gladwell says you need 10,000 hours doing something before you become an expert. I put in my 10,000 hours between 1961 and 1973, I'd say. As I said, interactive time sharing was coming in and gradually replacing batch for the kinds of things that my customers were doing. And I loved time sharing because it was very forgiving. You could see a syntax error show up on the screen and fix it right away, start your program again. Didn't have to feed cards in and drop decks on the floor and pick them up, stuff like that. But there was a problem, which was all the systems at that time had this thing called modes. To do anything, you got into mode this or mode that, and then you did things in that mode, and then you got out of that mode, and it was constantly like that. And from the very first time I used a program like that, I went, what's this about? What are these mode things? And everybody who I talked to said, oh, well, it has to be that way. That's the way interactive computing is. You go in and out of modes. It was kind of like the weather. Everybody complains about it, but nobody does anything about it. So I thought, I really should try to find a way to get rid of all these modes. But I was having trouble figuring it out too. Once you see a program with modes, and it's the first interactive program you ever saw, it's very hard to get your brain around a different idea, different way to look at it. And so I struggled for years to figure out how to get rid of modes. Okay. But that brings us to another takeaway, which comes from the fact that whenever I would bring it up with people, they'd say, you can't get rid of them. They're just a fact of life. Get used to it, you know. So the maxim I learned was, if everybody else thinks something's impossible, it's a great topic for research. So I thought, okay, I was at that time working for the Stanford AI Lab, and I could do research there. So in between my official duties of doing AI kind of things, I was trying to find ways to do them without modes, and having great difficulty doing that. In 1968, Professor Edgar Dijkstra published a letter to the editors of the communications of the ACM called Go-To Statement Considered Harmful. And that letter was read by everybody. Nobody read the rest of the articles in that issue. They all just read his letter. And that had more influence on the design of programming languages than any refereed paper, I think, that has ever been made. It was the foundation of structured programming, which today we don't even use the term because it's the only thing we have. So the name went away. So I thought, maybe I should write a letter to the editor saying modes are harmful, and then explain why. Then I thought, there is a problem. Dijkstra had solutions, but I had none. So I thought, okay, first I'll come up with some solutions, and then I'll write the letter. I never wrote the letter, actually. Too many letters got sent with similar names, and it became kind of old. But I started looking around to try to find ways people were getting rid of modes, or at least reducing modes, and kind of making a collection in my mind, and eventually, on pieces of paper. At Stanford, someone named Brian Tolliver had developed a program called TV Edit back in 1963. And when I first heard of it, I thought, this is going to be real easy to use. It's got two-dimensional screen. You go point at things with a light pen and do things to them, but it wasn't like that at all. It had a bunch of modes in it. Too bad. But in 1968, Pentti Kanerva, anybody know Pentti? Yeah, a few people might know him. He was at NASA for a long time. He ported TV Edit to the PDP-10, and he added a two-step move. Now, it wasn't the first editor to have a two-step move. A lot of other editors had it at that time or shortly afterwards. But the idea was that you would delete something, and it would go in a buffer. And then you'd move your selection someplace else, and then you would undelete, kind of, retrieve the buffer and put it where the new selection was. And I thought, that each of those two steps could be modeless. And then you'd have a modeless move, because a mode would mean that you're not allowed to do anything in between the two steps, but you could do anything between those steps. Nobody stopped you. So as long as you didn't clobber the buffer, of course. So I thought, this could be the basis of a modeless system, a two-step move. But his syntax was escape :G question mark 19 comma 44 and it was like not for a normal human being. but the concept was really good. And so he was the one that turned me on to that in a demo he gave me. Then I got exposed to cognitive psychology. I'd never taken a psychology class, I mentioned before, but I got a job at first as a consultant and then as an employee at the Stanford AI Lab. And at first I worked for Ken Colby, who was a psychiatrist. You may have heard of a program called PARI, the Paranoid Patient Simulator. That was done by Colby and his group. And while working for him, I got to know some people that ended up becoming founders in our field. Alan Kay, who I ended up working for a few years later at PARC, and then he worked for me at Apple. Don Norman, who everybody knows, I'm sure, and Terry Winograd, which you must all know. So Don and Terry would visit very often. Neither one of them was there, but Alan Kay, for a while, had an office just a couple doors down from mine. And he would come over a lot and see what we were doing, and we'd chat about stuff. And then he was the one that got me to go to PARC a couple years later. Another scientist I met at SAIL was Dan Swinehart. And Dan also later went to PARC. And he had a very similar objection that I did to modes. He was almost the only other person I met who thought we should do something about it. But he was building interactive systems. He built an editor called E that was kind of like a TV edit. And it became a very popular editor, but it was full of modes. But he kept trying. He would come in one day and say, I figured out a way to make this mode less onerous. You can do such and such while you're in the mode. And for example, move something from one place to another while you're changing documents, opening a different document, that kind of thing. So we started bouncing ideas off each other, and the collaboration continued when we went to PARC. And gradually, we started eating away at the modes. So from 1968 to 1970, I started getting involved in pay stuff. There was something called the Mid-Peninsula Free University. Who was involved here with the Mid-Peninsula Free University? A couple of people, not as many as I expected. We're getting old, Bruce. There was something called the Mid-Peninsula Free University. It's talked about in John Markoff's book. Yes, the Dormouse book. Anyway, we had a catalog and we had a magazine, and I used to go volunteer to help paste them up. And so we'd get a razor blade and we'd cut out things out of typewritten pages and take some white paste and stick it on the page and put it down. And that was called cut and paste. And as I was doing it one day, the guy I was working with, Jim Warren, who was at that time a math teacher in high school, started asking me what I did. And I said, oh, I do computer stuff. And as we were talking, I said, someday we'll do this on a computer. He said, what? I said, we'll be pasting things up on a computer. We'll just have files with edited text, and we'll bring them up on a big screen, and we'll move them around on the screen and plot them down. And we'll do that, cut and paste on a computer. So he said, really? And I ended up taking him to the AI lab and showing him Space War, and he got very excited about computers, quit his job as a teacher, and he was the guy that did the West Coast Computer Fair and Dr. Dobbs Journal and a bunch of other things. And that's how he got into it. But what it left me with was, cut and paste, two-step move, something here, something here. Still, everything was just getting filed away because I had day jobs and so on. But this was another step. It's kind of like once every year or two, I'd get another little incremental step here. But I did decide that I wanted to implement a page makeup system that was done on a computer screen. And those didn't exist then. So I thought, well, they probably don't exist because the hardware can't do it yet, but it will pretty soon, I felt. I'll come back to the 60s briefly in a moment, but I want to mainly talk now about the 70s. In 71, I became disillusioned with AI research. It was moving very slowly. I thought when I started at the AI lab, we'd have intelligent machines in a couple of years. So after a while, I realized, maybe a couple centuries, and this is not going to work for me because I'm a doer. I had a company, I did things for people, and I wanted to go back and do that again. And I thought AI would help me do that again, but it wouldn't be ready for a long time. So I wanted to really build systems. But I also kind of liked the research we were doing at the AI lab, and it's the reason that I eventually ended up going to PARC. It was kind of a compromise, working for a corporation, but in the research lab. But at that point, it wasn't PARC quite yet, and it was just about to start. But I went to Les Ernest and I said, I want to do something, and I want it to not be AI. And he gave me a list of projects, and one of them was a page makeup system, and I got pretty excited. And I said, interactive, we'll move things around on the screen. He said, no, we can't do that. There's not enough power in the machines for that. This is going to have to be a batch system. And so he told me he had this idea called the document compiler. And so that's what it was about. This was the cover of the manual of something I call Pub. And I know there's at least one Pub user here. One? Always, I guess, again, just one. Some audiences I find more. But what he meant by that was something that you could generate an index, table of contents, number sections, number chapters, cross-references, have that all be automatically done for you so that you could generate a document and make some edits and then regenerate it again with the compiler. And that would be a pretty powerful thing. Now, there already were some simple systems like this. There was something called Runoff, which evolved into TROF, which some people here probably have heard of. And, but Runoff was pretty simple. It had just a few commands, and it was a dot at the beginning of every line for a command, and no dot meant it was just text. And what we wanted to do was more complicated. So I needed to be able to bracket sections of the text and have that section be underlined and later bold and italic and things like that. Not yet. A little bit later, there was a printer, a Xerox printer that we adapted it to. But the first version was just done for line printers, monospace fonts. But we had in mind to extend it. Les was working on other projects about that. Anyway, so if we saw this language today, we would say, oh, this is a markup language with embedded tags and scripting. Scripting. Well, we needed to have computational power. And so Les said, you should have macros. So what I ended up doing was taking the Algol language that we had at SAIL, which was also called SAIL, and implementing an interpreter for a subset of that language that dealt only with character strings, kind of like JavaScript. So this was JavaScript in 1971, but instead of looking like C, it looked like Algol. And people did some pretty powerful things with it, things you really maybe can't do with JavaScript. I'm not sure. It was a different kind of, it had a lot of differences, but it also had some similarities. When I first started, I was very committed to making it as easy to use as possible. But then a terrible thing happened. Somebody walked in my office who was developing their own markup language and heard that I'd been doing this and said, you got to make yours compatible with mine. And he was a bit of a salesman, and he convinced me that compatibility was more important than ease of use, and gave me the whole history of computing up to that time, which wasn't very long, and about how those who establish standards are the winners. He was right kind of about that, but his language was so full of inconsistencies. The verb to start a block was completely unrelated to the verb to stop the block. And you had to memorize 2 words for everything. It wasn't just an of the first one like I was doing. So I went, oh boy. Well, okay, I guess he's right about standards. So I went and I did that. As it turned out, he never finished his product. So when Pub went out there, nobody even knew why I had made it so totally inconsistent from one thing to the next. And so that was very humiliating, and I swore I would not take that kind of advice again. And the lesson I learned was never be compatible with a bad user experience. So skipping ahead to 73. What? Okay, well, I actually have that in my talk. I'll take one more minute. So a few years later, I was already here at PARC. A couple of things were developed by users of Pub. Brian Reed at Carnegie Mellon developed something called Scribe, which was kind of like Pub, only made for non-technical people. And one difference was that he had tremendous consistency. And then Don Knuth, who was also a Pub user, hated all the inconsistencies in Pub and decided he would do his own language. It ended up being called Tech. And he was very adamant about always doing it right, never making the mistakes that Pub made. So I was embarrassed, but at least the outcomes of that were pretty good ones. Both programs did well, and of course, tech is still used today. Okay. So in 1973, finally, I joined PARC. I had known people at PARC for a couple of years. Alan was trying to get me here. And when I came to work with Alan on Smalltalk and to work on interactive page makeup, but that wasn't to be at the beginning because Alan didn't have any headcount. He never really had any headcount. He kept hiring people some other way. Eventually, he got me. And nobody wanted to do interactive page layout, even though it was Xerox. And I thought this company would definitely want it. And they said, well, yeah, but not yet. First, we're trying to build an office system. We're trying to redefine the company. It's going to be office systems. Okay. So I started working on office systems and found out that they were basing their systems user interface on NLS, Doug Engelbart's NLS, which you must all have heard of, I hope. Anyone who hasn't has got to go read about NLS and something called, was it World's Greatest Demo or something like that? The mother of all demos, thank you. The mother of all demos. NLS had a mouse, the first. It had tiled windows, not overlapping, but windows. It had views, even filtered views of things. It had outlining, hypertext, collaborative editing between different people on the network, video conferencing, and other stuff with some simple primitive graphics. And it was all wrapped up into something in 1968. ARPA funded, of course. And it was really an amazing thing. And I loved it except for one thing. It was full of modes. I mean, beyond everything else. It had modes where everybody else had already solved the problem. They were still doing modes. And proud of it. And in some ways, it felt like it made an extremely general system. And I won't go into all the details, but I'll give you a little bit of it. But it seemed to them to make it fully general, and nothing less than this could be general. And they were very attached to it. And I could not talk them out of it at SRI. But I was thinking maybe I could talk out of it the people who had come to PARC. And that ended up being the case. But first, let me just go quickly. I want to show you what mice look like. The top 63 was Engelbart's first mouse, one button. By 68, they'd added a couple more buttons. That one had 3. There were 2 wheels on the bottom, so it could tell which way you were moving it on the desk. Around that same time, there was a mouse developed in Germany and actually became a commercial product. It was called the Rollkugel. And that originally had no buttons. You moved it around, then you hit a key on the keyboard. Then they realized it made some sense to have a button on the mouse, and they put one on. When I got to PARC, we were building the Alto and using a Nova temporarily, and we were getting mice built that had 3 buttons. One mouse kind of looked like that. And there was another mouse that had the buttons laid the other way. We couldn't decide if they should be side by side or on top of each other, 1, 2, 3. So, and we color-coded the buttons on some of the early mice. And so the name stuck even though the colors stopped actually appearing on the buttons. But that's the mouse we had. The 3-button mouse was what we had to work on when we were developing the graphical user interface. And so we never really got to experiment with having 1 or 2 buttons, but we did experiment with not using the buttons. Couldn't take the button away, but you could just not use it if you wanted to and see how people could do with fewer than 3. And that was done. So I'm going to speed through this part a little bit. NLS had a verb-first syntax. You'd say, like, delete. You'd type a W to mean word. You'd click something with the mouse to mean, here's the word. You click anywhere in the word. And then click another key to hit OK. And you could do this without ever actually touching the keyboard, because there were 2 gadgets. There was a mouse that had 3 buttons on it, and they weren't used just to indicate where you are. There was a button to mean OK. There was a button to mean, oops, I just made a mistake. Go back 1 in this sort of state diagram. And there was another 5-key corded key set that was used for typing the names of the commands and things like that, and the scope. Here was another kind of command where there were 4 steps and maybe 5, where you could insert, before a word the thing I'm clicking now and then do it. And you could, click something else, which is the thing you wanted inserted. And that's how you could do a copy. But you couldn't really copy from another document this way. That didn't work so well. Now, I knew that the syntax forced this kind of overhead. The average command took about 6 keystrokes. And I thought, wow, this is just not only complicated, it's slow. It's a lot of keystrokes. And I knew that that wasn't necessary because IBM and Wang had come out with word processors by then, and they were dedicated machines, and they did have modes. But at least they would first move the cursor somewhere and then give a command that would operate on that. So I knew that was a possibility. So in '73, I started running user studies. And I was a little bit familiar with it from the work I had done in the '60s, but there was actually somebody who was a psychologist on the staff, Barbara Deutsch, and she knew about how you run a study like this, and she taught me some things, and that was very useful. One of the things I ran was a blank screen study. This was actually a study of the NLS-like editor that we had developed at PARC. But I also ran a blank screen study and had a secretary edit a document according to some markups on a page, and she would point at the screen with her finger and say what she'd do. I'd click here, I'd hit a key on the keyboard saying, move or something, and then I would click there and hit another key, so she would make something up as she went. And one thing I noticed was that she did this thing where she touched the screen and drag her finger across it and let go. And I said, what are you doing? She said, I'm deleting something. And I went, that's not a gesture that we do. So I looked into it, and it turned out that the way NLS was is that anytime you push the mouse button down, you just did a click. You never did a click, drag, and then release, because mice were so inaccurate that you couldn't get anywhere near where you meant to go. And not only that, the first place you clicked, you couldn't even get near it. So you'd click there, the mouse cursor would end up being a character or two away from the right place, and then you'd move over till the arrow was just in the right place, and then you'd let go. So just to get one point accurately took an entire cycle, and you could never use it to get 2 points accurately. That was out of the question. But at PARC, we had improved the mouse a little bit, but nobody went back and revisited this rule that you couldn't do it. And so I tried doing drag up, and people were pretty much able to do it, but still had difficulty with it. So I came up with a heuristic that you can ask me about later if you want to know what it was. But it solved the problem, and people were able to drag and select from any point to any other point in a paragraph pretty easily. Okay. So I wrote the conclusions of my user study, and there were a few conclusions that endured. And they may seem very obvious, but NLS didn't follow any of these 4 principles. Some systems followed a couple of them, but NLS didn't follow any of them, and that's the thing we were trying to follow. Character keys type characters. Hit a D, types a D. No, D might delete, or it might enter a mode to do a delete. Intuitive use of a mouse to point at things, to specify coordinates, basically. And nowadays, we use them also for scrolling. But at least all that has to do with the place you go matters. But they were using it as just extra enter and escape keys on the mouse that didn't matter where the mouse was. It wasn't a pointing operation. It really confused people. And then a couple of other things that we still do today. Then there were a bunch of things that mostly had to do with training that I thought were really important, that over time we realized wasn't really important. And so really none of these things are done today. Okay. Here is a memo from June 1973 where I talk about something called cut and paste. And this was an unusual thing because I also had, if you look to the left, delete and insert. And remember before I said you could replace, use delete and insert to do a cut and a paste. But what I was thinking at the time was that this was going to be a combined text editor and page layout program. And that for text editing, you'd use the delete and insert keys, and for page layout, you'd use the cut and paste keys. So this looks like it was where the idea was captured, but I still was a little undecided about all this stuff. Here's another cut I made one day. I have lots of pages like this, where I had move and copy being 2 keys on the chorded key set. And another version of that was cut and paste, and you'll see in a moment what it ended up being. And then I didn't yet have this red, yellow, and blue color coding for the mouse buttons. I was thinking we would use symbols. Dot, dash, and damn it would be the 3 things. And I think by the end of the day, I decided that wasn't probably the right thing to do. People had a lot of objections to cut and paste. One was that the phrase cut and paste, first of all, wasn't generally in the English language at that time. Of course, it is now. And it was not familiar to people, and except in the publishing industry, and in there, it meant usually something different. Not text editing cut and paste, but page layout cut and paste. Second thing was that users would make mistakes. They'd leave things in the buffer and forget to take them out again, and they'd clobber the buffer. And sure enough, I bet everybody's done that sometime. And that was before undo was as smart as some undos are today, and was even could even back you out of that error. Well, yeah, they have a good point there. And the other one was extensibility to other applications. They said, how will you do a drawing program? And we had a few drawing programs, and they all had modes. And they didn't bother people because you're looking at the screen and you were seeing the cursor change, stuff like that. So, okay, well, we don't need to get rid of all modes, but just the bad ones. So, still, they kept pointing out that it had some flaws. And for a while, I kept trying to cure the flaws. And at some point, I realized we just were going to have to live with them because even though cut and paste wasn't perfect, it was pretty good. It's kind of like democracy. Not good, it's not perfect, but it's the best we have. Still, I needed to demonstrate in a real program, cut and paste. And I built a little toy program, and people could learn it in 5 minutes. They came off the street and played with it. And it had no modes, but it didn't have cut and paste yet. So I was starting to get somewhere. But then a stroke of luck happened. Xerox had acquired a publishing company called GIN. It was an education textbook company. And GIN, like every other subsidiary of Xerox, was paying a tax every year to fund Xerox PARC. And PARC didn't have any other income at that time. In those days, it all came from Xerox. So the editors from GIN showed up one day and demanded that we do something for them. We need something for our money. We don't care about this Office of the Future kind of stuff. So people knew that I was interested in publishing. I talked about it all the time. When are we going to start doing that? And so my boss, Bill English, came to me and said, well, how would you like to work on a publishing application? And I went, yes. So I started doing that. And when we explained to them about this idea of using cut and paste for layout, and they liked it. And then I threw out, well, what about if we also used it for editing the manuscripts and the galleys? And they liked that too. Oh, cool. That's pretty cool. So we get to do it now. So Dan Swinehart ended up being a consultant on our project, but we needed somebody to actually go run a field study, not in a football field, but at Ginn and Company in Massachusetts. And so we hired a guy who knew a little bit about that kind of stuff. His name was Tim Mott. And he went to Ginn for a couple months, studied the way people used the editors that were there, the editing equipment that was there, and paper systems, and came back and said, okay, I'm ready. Let's design something. So we designed something called Gypsy, which was about as modeless as you can get, about as modeless as systems are today, and had in it a lot of things that we take for granted today. It was really easy for us to build because we took an existing editor called Bravo that PARC had just developed. Charles Simone and Butler Lamson and so on had just developed. And we threw out all the user interface code, which was conveniently in one module, and we replaced it by our own. So it just took about 3 months or something. But that was 24 hours a day, taking turns. We had very few Alto computers at that time. And in order to make sure nobody else got the computer, Tim and I worked 14-hour days, overlapping an hour on each end. And so we'd come in, show each other what we just did, and then go off and work for 14 hours, until the other guy came. And we did that for a couple months. Okay, so some of the things that Gypsy did for the first time was that you could click between characters and place an insertion point. It was not a vertical line in that yet. That was a couple years later. It was a little caret mark, which is what the Ginning Company wanted. But up to that time, you could select a character or more, not less. Now, there were programs that let you indicate a between character space conceptually, but this was actually a little mark that went between the characters. And when you just started typing, it would insert. There was no insert command. That was a surprise. Most programs had insert commands, not all. Some of the word processors didn't, like the Wang. But second one is that you could down drag up to select. And as I explained to you before, why that was not possible until just about then, with the help of this little heuristic I did. Another thing is, and this was Tim's idea, you could double click to select a word. So that took care of the main kind of selecting things. And there were some other things like dragging down the margin to get lines and paragraphs and stuff like that. Also, there was something called a wastebasket, which is today what we call a clipboard. And that's because when you cut, things would go in the wastebasket. But when you pasted, they'd come back out of the wastebasket and be copied into the text. At the top, there was a scan command, which was kind of like a find, and there was also a substitute command. It wasn't in this diagram from the manual. And that wasn't new at all. Find commands were in every editor, but usually you would type like Control F and then a string to look for and then return or something. And if you made a mistake, a typo, before hitting return, you'd have to backspace to get back to the place where you need to make the change. And if you had already hit return, you had to start all over. That's the way the systems tended to work. And there were ways to kind of not type everything if you had a terminal, but basically it was kind of like that. Here, you could click inside between those two braces and just start typing. And you could type your search key that way. And that's where the find dialog box first appeared. So one lesson I learned from that was, working with Tim, was you don't have all the answers, team up. So this became the modeless syntax, had half the number of steps. And if you made a mistake, it wasn't a big deal. If all you did was double-click a word and then hit a command, well, if you hit the wrong word, just double-click a different word. If you hit the wrong command, just say undo. So we didn't need all these extra confirmation, keystrokes. Just made it a lot quicker. These are all the editing commands in Gypsy, and all the green checks, you don't have to read them, but all the green checks were things that we still do today. All the X's are things that didn't really work out. And the checks and X's together occasionally, three of those are things that, well, we don't do it exactly that way today, but it's pretty close. So this was the first modern text editor. One thing we discovered pretty quickly was that we had designed it so that that one button alone was enough for most of what you had to do. And we considered that the beginner subset. But then we had the other two buttons were just there, and we had to use them, so we put advanced functions on those two buttons and started playing around with different metaphors. But it turned out that the users almost exclusively used the one-button subset. The only thing that they used another button for was that at that time, double-click could only be done on the second button for reasons I won't get into. But that was what influenced me when I went to PARC to Apple to get down to one button really. Okay. So this is very fuzzy. It's out of a video, but there's what the Gypsy key set looked like in a selected paragraph of text, scan at the top, and so on. Here are all the people that worked on Gypsy. We had a field study done at the beginning by Tim, and we had a field study done at the end by Betty Burr and Ralph Kimball, who found a lot of problems, actually, a lot of them having to do with software reliability. The frequency of crashing was such that the ease of use didn't matter. In 1976 or so, Dan Ingalls adopted cut, paste, and copy and undo into Smalltalk. And that's actually really where the modern systems have gotten it, because he did it exactly like we do today. Vertical insertion point, drag through and highlight in black, and only one button used for that. Although, like us, he had to use the other two buttons for something. So they were used to bring up various Smalltalk menus. So this is actually a picture from a Xerox publication that they happened to walk into an office and snap a picture, and I was the guy sitting at the computer. So there's an Alto keyboard. Here's a little 5-key key set with cut, copy, or cut and paste, and scroll arrows on the keys. Stu Card still has that key set, and this was the Gypsy manual that I still have. Let's see. Business Week wrote an article, came to PARC and wrote an article about what was going on at PARC and what was going on at IBM that they thought was, kind of competitive to what was going on at PARC. And there's some mention here, first time, June 75, of cut and paste. And it was actually about a program Swinehart had done. He also borrowed cut and paste from Gypsy and put it in something called Woodstock, which was more of an email kind of program. And it mentions Gypsy, though, in the lower box without explaining exactly how it works, but the fact that it's being used again. So it was no longer a big secret of Xerox anymore. Okay, just very briefly, I want to talk about the 80s. I went to Apple, worked on the Lisa. We got some ideas from Smalltalk, like cut, copy, paste, undo, but mostly did and overlapping windows. But we did lots of other things. And the Lisa, if you've ever seen it, you'll see is very similar to the Mac. Mac was kind of originally a baby Lisa in its user interface. And this is kind of what the menus look like. We had the file menu, then called file print, edit menu, just like today. This was a particular application that had its own menu. And then there was a clipboard icon because we were worried that people would always want to know what was in the clipboard. And so we made it so you could just double-click the clipboard icon and take a look. From Smalltalk and Bravo X, which was a revision of Bravo to adopt some of the ideas from Gypsy, the cut and paste spread to the rest of the world as people from PARC, some people from PARC left and went to join other companies and appreciated why these things were good ideas and convinced the companies they went to do it. And that took us all the way to Mac and Windows and to the situation we have today where it's just universal. From Mac it went to the iPhone, and from there it went to Android and Windows Phone, and just basically it's become a verb to the point where I've even read people say Engelbart invented cut and paste when he had no cut and paste. What they mean was he invented cut and paste, which he didn't either, of course, because lots of editors before that moved things around. But people don't know there's another name for cut and paste. That is the function in their minds, what you call it. So that is the end of the story. Now I'm going to answer the questions that I put in the brief. What's it like to design a user interface for 6 billion people? Well, I did have in mind, not the number 6 billion, but something that could be used in every application by everybody. That was kind of my assumption, because it was pretty well known by the end of the 60s that computers were going to keep progressing very rapidly. There was Moore's Law in 1965. We could see things just changing at an incredibly rapid clip. And from my experience with my first computer, I knew that I wanted one at home one day. Everybody's going to want one, right? So eventually, every office, every home would have one. And so I was aware that things that we were all doing, especially here at PARC, would eventually go everywhere. When I went to Apple, it became very different. Now suddenly, we weren't just dreaming up ideas and trying to perfect them. We had to ship something. And so the ideas had to stop at the state they were in and just freeze and become in the product. And that's what we did. How is creating a user interface paradigm different from designing an application? Well, one thing we did was that we would make sure, first of all, that all the applications we were doing and all the applications we knew third parties were doing would all be handled by the UI paradigm we were designing. And not only that, we would actually sit around and brainstorm applications that didn't exist yet, maybe in research labs, maybe not even in research labs. And, okay, well, how would you do something like that? How would you do a 3D graphics program? How would you do, the databases with these kinds of constraints? And, and just make sure that there was a way to extend these concepts. So you need to do that when you're designing a paradigm. If cut and paste was a new paradigm, in the 70s, what old paradigm did it replace? Well, it replaced word processors, which had some modes and lots of function keys. And it replaced NLS, which was, up to that point, the primary driver of thinking in universities and research centers about what the future would be like in terms of these kinds of interactive systems. Because that was the best one at the time. And it took this much change to improve on it. Missionary, zeal, and serial collaboration. What role did they play? Well, you saw all the mention of names of people I worked with. I'm sure I even left some out. And I only did a little part of the story. And there were many things that came out of PARC that have to do with the GUI today, and then came out of other companies after PARC's decade that I was there, starting in the 80s. But the little sliver that I was working on was fundamentally enabled by the collaborators that I had. Participatory design, I've already talked about that. We did a little bit of it even at PARC. Rapid prototyping, we did a lot of rapid prototyping, especially at Apple, where Bill Atkinson and I would alternate. I'd be working on user tests in the day, and then he would take the things I found that night and code improvements so the next day I could test the next batch of users on a different version. And we did that for several weeks straight until he had an auto accident on his way to work because he hadn't gotten enough sleep and almost killed himself. Okay. What accounts for the longevity of the result? Well, again, it's not perfect, but it's hard to beat a two-step move when things are going on that you need to change context between the first step and the second step. And it just seems always to be necessary. I was surprised when I saw mobile phones come out with cut and paste. I thought, oh, you'll just drag things from one place to another. But same problem. You gotta change context. It's change applications even. Do things over the network. It's just not okay to do it in one step. The other factor is, of course, that once we develop habits, they're hard to break. You're not going to reverse the brake pedal and the gas pedal, or change the direction you turn the steering wheel, or the QWERTY keyboard. They're very hard to break. Last question, what's the prognosis for today's mobile UI? Well, I don't think I have any great profound insights here. If you really want to know, you should ask people that are under 25 years old. When I was pre-25 years old, I was looking at the future. Now I mostly get to look at the past. But I can see what's going on in the short term. And gesture systems, obviously, are becoming popular. And one of the questions I have is, will there become standardized gestures? And how many will there be? And my current guess is that it won't be standards committees developing gesture standards, but there'll be entrepreneurs and business people developing them, getting them in the market and see what works. And they'll become a vocabulary of gestures, and ones that are widely used, like cut and paste being widely used, that kind of wide use. Everybody uses them every day. Probably it's going to be a slowly growing number. Maybe every 2 years, a new gesture will become established on the average, is my wild guess. But speech is becoming very important. When I gave my talk in May, that was before the big announcement from Apple about Siri, but Android's got speech control also, and Apple had a little bit before that. Speech-driven interfaces, what we're calling now eyes-free interfaces, are very important in lots of situations because driving and lots of other things like that. But also, the next shrinkage is probably going to be, down like wristwatches, Dick Tracy kind of stuff. And, you'll be able to talk to your watch and give in speech. So I expect that to happen. So I told you I'd summarize all the takeaways at the end. From the Cart Stunts project, I learned that unless you want a career in operations, build software that's bulletproof. From Pub, I learned don't be compatible with a bad user experience. From watching experts use NLS and typing twice as many characters as you really needed to get the job done, they would go really very fast with both hands, and they looked like they were accomplishing a lot, but they were just hitting a lot of keys. And in half the number of keys, you could get that work done. So, I didn't mention it earlier, but never confuse busy with productive. A lot of things I talked about had to do with collaboration, and you don't have all the answers, team up. From the difficulty of eliminating modes from text editors, if everyone else thinks something's impossible, it's a great topic for research. But you need to persevere. It took me 7 years from when I first thought about cut and paste until 75 when I finished Gypsy, and another 9 years before the Mac shipped. So things that have a big impact sometimes have to take a long time. Probably less these days. And one thing I learned at Apple, which I also didn't bother to talk about in the talk, was if you've got a product to ship, you won't keep arguing. Somebody like the founder of the company is going to walk in and ship the product. And so one takeaway I got from that was that if you're going to fight an uphill battle, choose a short hill. And that's it. Mike.
So Larry, cut and paste is all about copying content. NLS was richly structured probably because of all the tagging. What about copying and pasting structured things as well as amorphous pieces?
That's really an issue of selection, not copying. So in many systems, a certain gesture, or a certain double click, or a double click drag, or something will get an entire link, for example, in a hypertext document today. So it's really, and once you selected it, you can just use copy and paste. So it's really an issue of selection, what you're bringing up, I think. Somebody raised their hand there?
Yeah. With the discussion of the placement of the cursor and the accuracy of the early mice, you touched on the fascinating point of hardware being behind what you want to do with your UX, and sometimes we have the opposite case that the hardware is ahead and we don't know how to use it, which kind of feels like where we are today with multi-core processors. Do you have any further thoughts on that point of hardware and software leapfrogging each other and learning how to use new hardware?
I think you've made a good point, and having too much hardware, like I haven't figured out a way to fill any disk drive I bought for years, even though it used to be I couldn't figure out a way to get everything on it. Now it's the other way around. But I'd rather have that problem of too much hardware, frankly. But eventually, people start slowing down their purchases when they don't see any need for the additional hardware. It doesn't give them much benefit, and hardware companies always struggle with that. But but I think that's why people are looking for other things to do that we don't think of as requiring more resources, but can. Like doing speech recognition is a good way to use up lots of fast cycles, lots of processor. How about Ken?
So, Larry, I think the great thing about mobile devices is it's forcing us to get out of the WIMP mentality that we've been in since 1975. I've always been disappointed, at least until recently, that you and I are still doing the same thing in our computer today that you and I were doing in 1975, and that always kind of bugged me. And going back even further, you were talking about the disappointment in AI. I was always hoping that by the turn of the century, I'd just be talking to my computer and it would be doing what I wanted it to
Right.
do. And we're starting to get there. It's not artificial intelligence, but it's access to incredibly fast networks, powerful mobile devices, and very clever programming for things like Siri, for example.
Mhm. That wasn't the question. Good. You're not waiting for an answer. Good. Comments definitely welcome. Easier for me, too.
Throughout your career, what surprised you the most? And as a follow-up question, what piece of advice did you receive that you found most valuable that you'd want to pass along to future generations?
What surprised me the most in the computing field?
Yeah, let's limit it to that.
I think it's very hard to beat the very first time I read a computer manual and just found out that there were these gadgets that you could program that would do exactly what you wanted them to do. I don't think anything's matched that first moment. Well, that was the immediate disappointment the first time I submitted a deck. Then I found out it was do what I mean, do what I say, not what I mean. And Warren Titleman, who developed Do What I Mean, actually had a big influence on the way I thought about stuff. Obviously, including undo, and a lot of the software we developed at PARC was inspired by Warren. And the heuristics that I mentioned but didn't describe are kind of Do What I Mean heuristics. How you select something with a jiggly mouse. We try to figure out what you meant to select, not actually where the mouse went, and did a pretty good job of it with a very simple heuristic. And then there was another one that'll take too long to explain. Yeah, I think Do What I Mean. But yeah, that was the biggest surprise.
And any words of advice for future generations?
Advice for future generations. Well, I think the takeaways were what my advice is. And if I think of anything else before we walk out of here, I'll tell you.
Have you thought more about gestural languages? Can you talk a little bit more about what you think is on the horizon from
Well,
that? And does it include icons?
Yeah, I've seen demos, and I'm afraid I won't remember right on the spot, who they were, what university they came from. But at CHI 2010, I went to some gesture session and was amazed. I was amazed, not surprised, but amazed at what I was seeing. Just things I never would have thought of that had to do with ways you could use gestures to control things. Just depending on whether you grab something with one finger or two, that those essentially create constraints, and then you take your other hand and do flicking motions, and it does what a physical object would do if you had, if you constrained it in that way. I can't remember the exact details, but some of it was just thinking of clever ways of making things intuitive by making them follow physics. What would really happen if you touched it this way? But I had never imagined touching objects in that way. These guys have come up with some very clever ideas in that regard. But I don't even try to become a gestural language designer. I'll leave that to the young folks.
Since you're talking about the Lisa, could you just mention something about your experience with Steve Jobs? Might be interesting.
Experiences
Was that
with Steve
the
Jobs.
uphill battle in the short hill?
Yeah. Let's see.
As a UI designer, I know
Yeah.
he wasn't one, but I mean, that's
Well, I'll just give you a couple. One was more about my working relationship with Steve Jobs, which was when I first got to Apple, he said, I want you to go off. He wasn't my boss or anything, but he didn't care about that. I said, hello. He said, oh, Larry, come here. Come in my office. I want you to go and develop something about the user interface. There was some specific thing he wanted me to work on. And so I started working on it. And then somebody came to me and told me that they were working on it. And I went, oh, why are you working on that? Oh, Steve pulled me in his office and said he wanted me to work on it. So I went banging on Steve's window. I had just started there about a week before, I think. And we had glass walls, and so I was banging on the glass walls. Like, I went in and closed the door behind me and just chewed him out. And I guess I was 10 years older than him. Maybe I thought I'd get away with something like that. But I thought, this is not acceptable. And I had never experienced anything like this at PARC. So he said, oh, okay, I apologize. I won't do that again, but I won't go around you like that. But I have an idea. Why don't you two work together? And so in fact, he wanted 3 of us to work together, and it was me, Bill Atkinson, and Jeff Raskin. And so the 3 of us went to Jeff Raskin's house and spent a couple of afternoons. Most of the time, Jeff was playing the piano, and once in a while would get up and express an opinion about something that would get Bill and I in a tizzy for another hour while he was playing something else. And but out of that grew some ideas for how we would manipulate overlapping windows and things like that in the user interface. And then Jeff kind of lost interest because he didn't like the gadgets. He didn't like the mouse, and he had a very different notion and kind of didn't want to be involved anymore. But he stuck around long enough just to endorse the one-button mouse that Bill and I had been fighting for, and that he was even a bigger advocate of, I think, at that point. So once we got settled on the one-button mouse, he just kind of said, okay, well, at least it's only got one button. I don't like mice, but anyway, so Steve set that in motion. And let's see, UI. I can't think of any specific incident, but whenever we would do something that was kind of cool, somebody would bring it to Steve and give him a little demo. And he would get all excited about it and then come around shortly afterwards, as soon as he could get away from his building into ours, and come and just talk to everybody. And I'm so excited about what you're doing. This is really great stuff. So he had a huge appreciation for exciting things that people could relate to. They had some beauty to them, some elegance, and ease of use. It was very important to him. And he rarely generated an idea for us during that time. He more selected from options we would give him. And he was damn good at selecting the best option in retrospect. So he settled arguments right away, because who was going to argue with Steve? So we just did what he said. But if he had made bad choices, we could have had a very different result. And he made a few major bad calls in his career, but mostly he made really, really great calls about UI and everything else. Okay, far corner.
Yeah, you mentioned end-user programming in the early days of your career, and then I don't think it really mentioned it again. So what's your observations and kind of reflections on end-user programming, and what might we expect for end-user programs that kind of execute natively on the net?
Okay, well, I did work again in end-user programming, but more as a manager than as an individual contributor at StageCast with Alan Seifer and Dave Smith, who had developed something called Coco originally, and then it became StageCast Creator. I tried to keep the company funded until we couldn't anymore for several years. And that product is still being sold, but it's really an aged product at this point. That was for kids to do games, like Pong-like games. Very limited domain, and we stretched it some, so you could do certain kinds of simulations with it, but all had to do with animated characters on grids. So, kind of brought me back a little bit to my card stunt days, where we had, that also was an animation language for non-programmers to develop software in. So it was kind of a revisiting of early 60s for me, and it was 40 years later. But do I have any opinions about where it's going and cross-compilation on the net? Is that?
No, just moving beyond like simple things that we'd think of running on our own computers and thinking of end-user programming as a way to...
programming the net, the network itself, or activity on the network.
Yeah.
I haven't thought a lot about that. And just a particular client-server kind of interaction, I have seen that done. I mean, Alan Seifer's done some work with web browser macros, essentially, and that's between his server and your machine. And in Stagecast, we did a version that was where the simulation ran on the server, and it had the client do just the graphics. But I really haven't thought about it much, so I couldn't really give you a good answer.
So this is the final question.
Do you still feel the same way about one-button mice now over two? And what's the role, if any, of modifier keys? How do you think that's all playing out?
Okay, great question. So there was a guy named Tom Malloy who was one of the people who developed Bravo with Charles Simone at PARC. Then he went to Apple, got there before I did by about 7 months, and worked on Lisa Wright, word processor. And he and I had a friendly battle going all the time. He wanted a 2-button mouse. I wanted a 1-button mouse. And then he came to me one day to propose a compromise. He said, Larry, how about 1 big button and 1 small button? 1.5 buttons. Not 2. It's just 1.5. And I was tempted, but I thought, no, the point of this is not that we should never have 2-button mice or even 29-button mice, but right now, 99% of our users have never touched a computer before. And we want it to be dead simple, easy to explain. And yeah, once they get to the point where they're sophisticated enough to be knowing ways to use lots of extra gadgets, they won't, that's okay. We could do anything at that point because they'll understand computers. So I didn't think that 1-button mice were right for everybody forever. I just was thinking today, early 80s, on a computer for consumers who have never touched a computer before, we should have a 1-button mouse. So many years later, I had regrets and thought, we should have done a 2-button mouse. And I went and I confessed it to Tom, who's still a good friend of mine. And he said, well, Larry, I was going to confess to you. I realized that you were right to do 1-button mouse. I said, no, Tom, you were right to do. Anyway, that goes. So whenever we see each other now, we go back and forth. But the thing is about shifting keys is that when we had 2 buttons, the engineers would fight all day long about what should that second button do? Should it do what the option key does, or should it do what the control key does, or should it do what the command key does? Well, if you're going to have to fight about which of those things it does, it's not fundamental. 1 button is fundamental. The other button always does something different, and it depends. And it's not fundamental. So again, for beginners, why even confuse them by having it? They'll keep asking you, what button, what button, what button, and then you'll never get anywhere. So introduce it later, and by then they could program it themselves and say what they want it to do. Taking more?
Well, there's one other person.
Okay.
I don't want to cut her off.
Speaking of that, I've got one. What do you think of the user interface for things like the iPad? Some of it is extremely intuitive, but if you want to expand the screen because somebody is partially blind, you have to tap it 3 times, and if they're partially blind, sometimes they're old and they can't control that. So what's your opinion of the touch screens now?
Well, I agree with you. I don't use any mobile device except Apple, so I can't comment on the others. But on the iPad and the iPhone, there are definitely rough edges in the UI. And I think that results from a culture that evolved away from usability testing, which we did a lot of when I was there. Apple got to a point where, which I think is a valid thing, where they knew their customers so well, because they had a lot of people that had worked there for many, many years. They knew the Mac customer really, really well. And they had tens of thousands of developers developing for them. And they could predict the result of almost every user study correctly. And so why spend the money? If we're wrong once in a while, we'll fix it in the next release. When they moved over to the mobile devices, they didn't go, new domain, maybe we better learn this from scratch and run usability studies. They did for their website. They have people who test their website. At least they did. I don't know if they still do. Maybe they think they know enough now. But for years, they had people testing their website, even when they weren't testing for the Mac. But when it came to the small devices, they had one person, and still do, who basically makes the decisions. And he's pretty good, but we all make mistakes. And I think they haven't gotten to the point where they know their customer that well. For one thing, they're still acquiring customers at an enormous rate. It's a first generation, really a first generation product, even though they'll call it, a fourth or something. It's going to look really different in 10 years than it looks today. And accessibility is going to become one thing that gets a lot more emphasis. And I believe they are putting more emphasis on it now. And yeah, but it's too bad that some of the gestures are afterthoughts. Okay. You want to speak here?
No more speakers.
Okay.